Very good morning to all of you. I once again welcome you all to this current video lecture. In the last lecture, we completed the chapter called as the chemistry of hydrocarbons, that is alkynes. So up to this lecture, we completed the three different chapters belonging to chemistry of aliphatic hydrocarbons, that are alkanes, alkenes and alkynes. Now today we are going to start the first chapter from sequence in our syllabus, that is the fundamentals of organic chemistry. So this is a chapter number first from your syllabus, but in a sequence it is chapter number 4. So this is the fundamentals of organic chemistry. Now, as far as the chapter is concerned, it is a very important chapter as far as the basics concepts or the fundamental concepts of this organic chemistry is concerned. So in this chapter, we are going to take the different important fundamental concepts which are necessary to understand the organic chemistry. So we know that the organic molecules are made up from the number of atoms. These atoms are arranged together in an ordered manner in order to form the molecules. So we are interested to study these molecules. We are interested in order to study these molecules. Now, whenever these molecules are to be concerned, each and every molecule has some type of the properties. Each and every molecule has some type of the properties. Now, every molecule has the two type of the properties. One is the chemical property and second is called as the physical property. So, these are the two important properties associated with any molecule: physical and chemical properties. These are physical and chemical properties. So these are the two important properties associated with each and every molecule. Now in this current lecture we are going to take some important physical properties of a molecule that are to be important. Now as far as these physical properties of molecules are concerned, physical properties of molecule, physical properties of molecule. Now as far as these physical properties of molecules are concerned, we know the simple physical properties of the molecule. That properties may be its melting point, it may be its boiling point, it may be its solubility, or the next important property may be its dipole moment. Maybe its dipole moment is there. So that dipole moment is again important physical property of the molecule. So these are the some simple physical properties of a molecule. Now we have to take some important among these properties, physical properties. So first important property among this physical property is called as the melting point, melting point of molecule, melting point of molecule. Now as far as this melting point of the molecule is concerned, we have an idea regarding this melting point of the molecule. Now what is by this melting point of the molecule? So if we take a solid, or if I take a solid compound, for example, if I take a solid compound, and if we want to convert this solid compound into the liquid, means we have to convert the solid state into the liquid state. So for this purpose what I have to do, we have to apply some heat, or we have to apply the temperature to this particular solid. After that what happens, this solid get converted into the liquid. So as far as this melting point is concerned, so what is by this melting point? Before considering this definition of this melting point, we must know that solid compounds have the ordered arrangement of atoms and ions. It have the ordered arrangement. It have the ordered arrangement of atoms, or it may be the ions. So what happens, each and every solid is considered to be as a crystal lattice. So in the crystal lattice, these solid compound or solid molecules consist of the ordered arrangement of atoms and ions, due to which what happens, they have the very close packed structure. And so if we want to convert the solid into the liquid state, so for this purpose we have to supply the heat, or we have to apply the temperature to the particular solid. After that, what happens, due to the effect of this heat or temperature, the bonds present between these atoms becomes weaker, and due to which this solid get converted into the liquid state. So you can say that melting point is nothing but a phenomena in which your solid compound get converted into the liquid compound by the application of the heat. So this ordered arrangement of atoms or ions becomes the random, and that solid get converted into the liquid compound. So this is a simple phenomena of melting point. Now if we consider a simple example of one molecule, that is a NaCl molecule. If we consider the NaCl molecule, now what happens, this NaCl molecule is called as the ionic compound, and we know that these ionic compounds are a very much stable compound, because the strength of this ionic bond is a very high, and that's why these ionic compounds have a very high melting point. So if we this consider this NaCl's melting point, it has the melting point of 801 degrees centigrade. And why this is so? Because the ionic bond present between this Na plus and Cl minus are very strong. It is a very strong bond, and that's why we require the high amount of heat, or we have to apply the high amount of temperature to this NaCl in order to convert it into the liquid state. On the another hand, if we take the and covalent compounds, for example, if we take here methane, if you take into methane into consideration, its boiling point is a very low, it is a minus 183 degree centigrade. So it is a difference between these ionic compounds and this type of the covalent compounds. In covalent compounds, the strength of this bond is weaker as compared to ionic bond, that's why they have the lower melting point. So we can say that each and every molecule has a fixed value of this melting point, and this melting point magnitude or the value depends upon what type of the chemical bond is present between the constituent atoms or ions in a molecule. So this is the first important physical property called as the melting point. Now the second important property from this physical property is called as the boiling point. Second important property is called as the boiling point of the molecule. Now what do you mean by this boiling point? So this boiling point is a second important property for any molecule. Now these boiling point are very much important as far as this conversion of this liquid compound into the gaseous compound can be takes place. If we consider suppose a liquid compound, if we consider here a liquid compound, suppose initially we have a liquid compound, and if we want to convert this liquid compound into the gaseous compound, or if we want to change the state of this molecule from liquid to the gaseous state, then what happens, we have to again apply the heat, or we have to apply the temperature to the particular liquid. Then what happens, this liquid get converted into the gas, and that's why during this such a type of the conversion we have one important temperature, then that temperature is nothing but the boiling point. Now if we want to define this boiling point, then what is the definition for this? So boiling point is defined as a temperature. It is nothing but a temperature. So what is the temperature? The temperature at which your vapor pressure of liquid, your vapor pressure of liquid becomes equal, vapor pressure of liquid becomes equal to the atmospheric pressure. Vapor pressure of liquid becomes equal to the atmospheric pressure, then that particular temperature is called as the boiling point of the that particular liquid. Means vapor pressure of liquid becomes equal to the atmospheric pressure. Now what is meant by vapor pressure of liquid? Suppose if we take a particular jar. In that jar, suppose if I take water in a jar, if I take a water, suppose this is water, it is a water is there. So if we take the water in this jar, and suppose if we heat this water, if we apply the temperature or we heat, if we heat this particular water in a jar, then what happens, after some times the vapors get collected at this surface of this water, vapors get converted at the surface of this water, then these vapors are nothing but the vapor pressure. This is called as the vapor pressure of this water. This is called as vapor pressure, because we know that these vapors have some type of the pressure. So this is the vapor pressure of this water. Then what happens, we have to heat this water up to that extent at which the atmospheric pressure, this atmosphere has some type of the pressure, so these two pressures becomes equal. When these two pressures becomes equal in magnitude, then that particular temperature is called as the boiling point of the particular water. And we know that the boiling point of this water is a 100 degree centigrade. And why this is so, because at this temperature the vapor pressure of this water exactly becomes equal to that of the atmospheric pressure. So this is a very simple physical property called as the boiling point of the particular compound. Now, after studying this, the next important physical property is nothing but the solubility. This is a solubility is there. Now, this is a third important physical property for the organic molecules, that is your particular solubility. Now, what is the meaning of this solubility? So, as far as this word is concerned, solubility. So, solubility involves the two important concept. As far as the solubility is concerned, we have to take into consideration a solute. We have to take into consideration this solute. After that, if we want to suppose converts this solute into the solution state, if we want to convert this solute into the solution state, suppose, then what we have to do, if we want to convert this solute into the solution state, so for this purpose what we have to do, we have to add a next important parameter, and that's called as your solvent. We have to take into consideration a particular solvent. So what happens, the conversion of this solute into the solution state with the help of a particular solvent, then that simple process is nothing but the solubility. This is the next important physical property called as the solubility. So solubility is nothing but the conversion of solute into the solution state with the help of a proper solvent, then that is a solubility phenomena. Now what happens when we take a solute, when we take a solute and dissolve in a particular solvent, when we take a solute, dissolve in a particular solvent, then what happens, the solute particles, these solute particles or the molecules, they get separated from one another. These solute particles or the particular molecules get separated from one another by this type of the solvent molecules, and that's why what happens, due to such a type of the separation of these solute particles by the solvent molecules, they get converted into the solution state. Suppose for this purpose, if I take a simple example, suppose if I take one molecule, that is a M plus A minus, this molecule I have to take, or this is a, suppose solute is there, this is the solute, this is a solute suppose, and on this solute if we add a solvent as a water, and in this solute if we add the solvent as a water, then what happens, we know that initially this is a solute, this M plus and A minus have the close packing, they have the strong force of attraction between them. But as soon as we add the water as a solvent to this solute, then what happens, this M plus and A minus get separated from one another, and they form such a type of the two different cluster. This is a M plus is there, plus second is called as the A minus. First is M plus, second is called as the A minus. Then what happens, this M plus and A minus get separated from one another. And why they get separated from one another? Because they form such a type of the weaker force of attraction with that of the oppositely charged ions. They form the such a type of the weaker force of attraction with the oppositely charged ions. This is nothing but the oxygen. So this type of solvent molecules that are involved to form the weaker force of attraction between these positively charged ions to that of the negatively charged, this, O minus is there. Sorry, this is a minus. We have to take here A minus. We have to take here A minus. This is a M plus. Okay, we take here A minus. This is a M plus. So this A minus, that is a negatively charged ions, forms a bonds with that of the positively charged hydrogen from this type of the water molecule as a solvent. So it has the partial positive charge. It also has the partial positive charge. So there is a force of attraction between this type of the ions can be takes place, and due to which what happens, such a type of one solvated anion is there. This anion gets surrounded by the this type of the solvent molecule. In the same way, this M plus also gets surrounded by the oxygen from your solvent, that's water. This also gets surrounded by the this type of the solvent molecule. In this case also, this is a oxygen, this is a hydrogen, this is also the hydrogen. So we can say that this oxygen has the partial negative charge, and this M plus has the positive charge. This M has the positive charge. So there is a force of attraction is there from this cation to that of the anion. So we can say that whenever a solute can be dissolved in a particular solvent, then what happens? This type of the solvated anion and solvated cation can be formed. Solvated cations can be formed, and due to which what happens, the this type of the solubility phenomena can be takes place. So we can say that whenever a solute is there, that solute has the strong force of attraction between the cations and anions, but as soon as we add a suitable solvent, then these cations and anions get separated from one another. And why this is so? Because they forms a soluted anion and soluted cations by the formation of weaker force of attraction between the cations to that of the oppositely charged atoms present in a solvent. So this type of phenomena is called as the solubility. If we take the solvent as water, then that process is called as the hydration. If we take the solvent as water, then that process is called as the hydration. That process is called as the hydration. But suppose if we take any other solvent other than this water, then it is called as the solvation. Then it is called as the solvation process. So these are the two important words, hydration and solvation. No doubt in both these cases a solubility phenomena can be takes place, but if we take selectively solvent as a water, then it is called as the hydration. But if we take the another solvent, then it is called as the solvation. So these solvent, now these solvent are of two types. One solvent is called as the polar solvent and second is called as the non-polar solvent. So whenever we take solute, we have to take the proper solvent, and for this purpose we have to follow one simple rule, and that rule is nothing but the your like dissolves like. We have to use one simple rule, like dissolves like. We have to use one simple rule, like dissolves like. What is the meaning of this like dissolves like? Whenever we take a solute, and if we want to take a proper solvent, at that time we must take into consideration what is the nature of this solute. If suppose this solute is a polar in nature, you must take the polar solvent. On the other hand, if this is a non-polar solute, you must take the non-polar solvent. And so for this purpose we have to take the help of this simple rule, like dissolves like. So this is called as the solubility. So in the today's lecture, we started the first chapter called as the fundamentals of organic chemistry, in which we studied the different physical properties of the organic molecules, starting from its melting point, its boiling point, and next is called as the solubility of the organic molecules. Remaining important point we will take in a next lecture. So with this, today I stop here. Thank you so much.